Okay. So good afternoon, everybody, guys. So last time I started to explain interrupts. So uh, I, I I spent several slides here to explain number one to define interrupts. Number two to make you understand or to explain uh, how interrupts are important, why they are very useful, why you cannot make real system or real application if we don't use interrupts. And I can repeat the answer now just in one sentence. Okay. In this sentence, that using interrupts we can actually run multiple tasks. Okay, several tasks. This is the main thing you should fully understand. Okay, so because of interrupts we can run, as shown here in this figure, we can run multiple tasks. So now we're gonna have in the main program one task. We're gonna have several interrupt sources. So you can put one task in one source, another task in one source, and so on. And then what happens most of the time, the CPU is here in the main program, and then every time there is an interrupt, so you go serve the interrupt, come back, go serve the interrupt, and come back. And I told you what I mean by the word serve the interrupt. That means you execute the subroutine of the interrupt. Every interrupt source has what we call interrupt subroutine, right? When an interrupt is triggered, okay, you can service and to service this interrupt, we need to execute the subroutine. Okay, so I explained this last time. Also, I started to explain how can you program an interrupt. Okay, so this section, guys, in general, here I'm talking in general for any interrupt source, how can you program it. Okay, and then here, I'm going to repeat what I said here, but I will be more specific for IRQ. Here, I'm going to repeat what I said here, but it's going to be more specific for RTI. IRQ and RTI are two sources of interrupts. Okay, there are for sure other sources. Okay, the good thing is once you know how can you program one source, all of them almost the same way. Okay, so the first thing I explained here last time, guys, is how can you enable or disable interrupts. So let me maximize this one. Yeah. Okay. So what I said last time, guys, quickly, in your program, you have to write two instructions to enable interrupts. Two instructions. The first one, as I said, CRI, CR, oh, sorry, CLI, sorry, CLI. Okay, so this instruction should clear the I flag, this one, I flag here. Okay, and if you do that, as I said last time, that doesn't mean all the interrupts are enabled, but you have to do it because this is like a master key. But if you SEI, this one, so all the interrupts are disabled, right? So this is a first step. In order to enable interrupt, you have to do this one. This is a first step. The second step is every interrupt source has one bit. Okay, I'm going to explain later for each source. I'm going to be more specific to explain where is this bit. So every interrupt source has one bit. Okay, if you wanna enable the interrupt from this source, you can put one. If you want to disable, you can put zero, or the other way. So I'm going to teach later in details. So it's just one bit to enable or disable the interrupts of this source. Okay, so this is the first thing you have to do in programming. This is the first thing you have to do. You have to enable interrupts, right? The second thing you have to do in programming, guys, I told you about interrupt flag bit. Okay, and I explained to you the idea. Very simple how it works. Okay, if one device, so every interrupt source has also one bit. Okay, this bit is called interrupt flag bit. This bit is used in order to notify, in order to trigger, in order to attract the attention of microcontroller, in order to tell the microcontroller is I want to trigger interrupt. So the idea is that if this device want to trigger interrupt, so this device simply is going to put one here. So this one actually is going to trigger interrupt. Okay, again, this is done automatically. You don't need to do anything about it, right? So this is done automatically. However, in the interrupt subroutine, you have to write instruction in order to clear this one. So you need to write instruction to clear, to put 0 here, okay? And you clear it because you already served the interrupt. You already served the interrupt. That means as long as this bit is 1, that means there is outstanding, there is an outstanding interrupt. You got what I'm saying? You didn't serve it. So so once you execute the subroutine and serve the interrupt, you have to write instruction to clear it. Is that okay? Again, this is very serious, because if you forget to do that, you are going to have a continuous interrupt. It's like you have a device that always requesting interrupts, okay? So this is one thing I started explaining last time. This is also one thing you have to do in programming when you program interrupt. The other thing I said explained also last time, guys, is you can, as I said, every interrupt source should have a subroutine, right? And so where is this subroutine? Where you put it in memory? So the answer is you can put the subroutine anywhere in the memory. It's up to you, okay? You can put it anywhere. However, you have to tell the CPU where is the beginning address, right? Because once you give me the beginning address, once there is an interrupt, I'm going to execute an instruction from the beginning address until I find RTI. So I need to know the beginning address. So I give you the freedom to put it anywhere in the memory, but just let me know where is the beginning address. How can you let me know? As I told you, every interrupted source have to fixed location, 2 location. So every source has 2 location. All what you have to do, you have to write the beginning address in this location, okay? So here look at this part, guys. Here I'm saying we have vector address. So this vector address is actually the fixed location, right? If there is interrupt vector, this is the beginning address. So these addresses are fixed, but this one 4103 is not fixed. This is something you can change, okay? So now, here in this table you can see this is the vector address here, guys. Okay, so very simple. So if you want to program timer 0 channel channel 0 interrupt, so you can put the subroutine anywhere, but you have to put the beginning address in this location, right? This location and next one, right? Because if you see here, these locations are incremented by two, because every you need to state address in every location. Okay. Now, so how can you do that? We're gonna do that using org this way. Using org, you can say org ff2, for example, if you program IRQ, because if you go here, this is IRQ ff2, right? So, and then here you can say dc.w and then put the name of the subroutine. You can put any name for the subroutine, but just this can be any name, right? But just put the name here, right? Because I told you before, once you put the name of the subroutine is gonna be replaced by the address, okay? So this is something you have to do. So that means, listen to me. So that means if you have, so for every interrupt source, you have to do one like this one for every interrupt source. So that means, sorry. Sorry guys, just 1 second. Silent my phone. Okay, so so now your program now has more than one org, right? So as we know before, you have org 1000 for data, and then we have org 4000 for your program. Any equate has to be written here, any equate, right? So this new orgs, you can put it here after equate before this one. So you can have more than one org, you can put it here, it's okay, right? Or you can put it here, okay? Somewhere here, that's okay, but it's okay, you can put it here before this one, okay? This is also something you have to do for any interrupt source. The only difference, guys, is just this address will be different. This is the only difference based on the source, right? The last thing I explained last time is the interrupt priority, right? So what priority here means, look here. Now, I give you a scenario. What if there are multiple interrupts at the same time? Okay, so again, microcontroller can only serve one interrupt at a time, right? So if there is one interrupt coming from, for example, from IRQ, from RTI, from timer 7, right? So now there are 7 interrupts. Microcontroller has to select one of them, right? So because we cannot, I'm gonna serve all of them, but I'm talking about which one I have to do first, right? Priority. So so which one has more priority? So as I told you, what we do here, we have fixed priority. Fixed priority means the interrupt comes first here in this table has higher priority. So based on this scenario, guys, we have IRQ, RTI, and timer 7. Okay. So because IRQ comes first, I'm gonna serve it first. So once I serve IRQ, now I'm gonna see what interrupts now are requesting me. I'm gonna find RTI and timer 7. So I'm gonna serve RTI. Okay. Once I finish RTI, so now I'm gonna see what interrupts I have right now. Okay. If one interrupt come after during executing this interrupt, RTI interrupt, another one came. Okay, so now I have to select between 3 and 7, right? So I'm gonna do 3 first. Also, although 7 requested before 3, but we don't do it this way. It's not first come first serve. It's not like that. You got what I'm saying? So every time when I finish one interrupt, I'm gonna look at the interrupts, and then I'm gonna select the interrupt that has higher priority to serve. Okay. So now I told you we have fixed priorities this way. However, we have you still have very limited capability to change this fixed priority. How? I'm gonna tell you how. Look here, guys. You can, there is a register. This register is called HP RIO, right? High priority. This stands for high priority, right? So you have limited capability, guys, so that you can select. You can select one interrupt from here and put it on top of everyone. You got what I'm saying? You can do, but only one. It's only one. How can you do that, guys? You have to write a certain number to this register. Okay. Once you do that, you can put one interrupt above the other interrupts. Okay. So which number? How can you come up with this number? This number actually you can get it from here. From the address, from vector address. This number actually is the least significant byte. For example, if you wanna put a channel 3 on top, so you have to take 8 E8. Okay, so you have to take here the least significant byte and just copy it to this register. Okay, so you can do this way. Again, for the purpose of this course, we're not gonna do that. Okay, so I'm just explaining everything, so there is no need to do that unless you are doing like in your project you need to do something like that. But for the purpose of this course, we can follow this priority. We don't need to change it. Okay, another thing you should understand, this microcontroller has, as I said, just limited capability to control the priority. It allows you only to select only one, put it on top, right? But other microcontrollers have different capabilities, right? So it depends on but for sure every microcontroller has a way to decide or to determine the priorities. That's for sure, right? But it's different from one processor to other, right? Here it's just very simple. Okay, now so now let's I explain different pieces together. So let me put everything together to explain to you the complete story or complete interrupt service cycle. Okay, so it's like a cycle. Once the interrupt is requested until it is served, it's like a cycle. So we wanna I'm gonna explain this cycle. So number one, this cycle should start when the flag bit, the interrupt flag bit is set. That's what I told you. If you go back here, this one, so the beginning of the interrupt cycle, it comes from here, this one. When this device set the interrupt flag bit. So this is exactly similar when I teach a lecture and you want to interrupt the professor. So what you are going to do, you are going to raise your hand to interrupt the professor, right? So this is exactly the same thing, right? So here the device has to put one here to request interrupt. Okay, so this is step number one. After that, if the interrupt is enabled, so I'm gonna serve it. If it is not enabled, so I'm gonna just discard it. I'm not gonna do anything, just discard, right? So how I can know if the this interrupt source is enabled or not? As you see here, guys, as I said before, we're gonna look at the I bit to see if the I bit is 0 or not. This number one. Number two, I'm gonna look at the enable bit, interrupt enable bit, right? So yeah, also we're gonna look at I bit and the interrupt enable bit. We are gonna look at both of them. Okay. If both of them are enabled, that means this interrupt is enabled. Now I'm gonna move to the next step. Okay. Next step, I have to see, okay, is this is the only interrupt or this interrupt has higher priority or not? You got them? So let me say step by step. So number one, I'm gonna look at this one, guys. So if it is enabled or not. If it is not enabled, so just I'm gonna discard it. So I'm not gonna do anything. If it is disabled, right? If the interrupt is enabled, so I'm gonna move to the next step to see if this is the only interrupt we have, or this is the highest priority interrupt, right? So maybe I have multiple interrupts and this one has the highest priority, right? So in this case, we decide to serve the interrupt, and we're gonna start from here to serve the interrupt. Is that clear, guys? So very easy. In order to serve the interrupt, number one, it has to the interrupt should be enabled. Number two, it should be the only interrupt, or it should have the highest priority. Okay. Now we're gonna start serving the interrupt. So we're gonna start from here. Okay. To serve the interrupt, number one is the first step number 3 here, or this is the first step in serving the interrupt. So what's gonna happen? The CPU automatically pushes all the register, okay, 9 bytes in total to the stack. Is that okay? So as you see here, guys, so automatically all the register are gonna be pushed to the stack. Again, look here, I'm saying automatically. That means you don't need to write any instruction to do that. Okay, so this is done automatically. Okay, so this is number one. I'm gonna tell you why we do that. Okay, actually we did something similar to this one, guys. You remember in subroutines when we used to push some instruction in the beginning of the subroutine and we pull them back at the end of the subroutine? It's exactly the same thing here, right? But here you don't need to write instruction to do that, right? It's done automatically. So all the register are done automatically, pushed automatically, and also they are going to return automatically, so that if you change so that if you change any register in if you change any register in in the interrupt subroutine, this not gonna mess up is not gonna mess up with the main program, right? So because all the register are gonna get their initial values back. Okay, so this is number 3. Number 4, CPU should prevent further interrupted from occurring, as you see here. Look, till the interrupt is served, right? This is done by setting I interrupt. So it's like, so because I decided to serve one interrupt, right? So I'm gonna disable I'm not I'm gonna disable all other interrupts. Why, guys? Because it's not allowed. Nested interrupts are not allowed. So what this means? What I mean that, look here, guys. If this is an interrupt subroutine and this is another interrupt subroutine, right? If you, when this is the main program, if you move from the main program to one interrupt subroutine, right? What if there is another interrupt now? Should I leave this one and go to save this interrupt? And from this interrupt, maybe another interrupt, I move to another one? No, we don't allow that, right? This is not allowed because usually this does not give good performance, right? So what happens is that once we decide to serve one interrupt, guys, all the interrupts are disabled. Automatically. Again, you don't need to do anything. All of that are done automatically, right? So all interrupts are disabled, so that nested interrupts are not allowed. Okay, that means, that's why I told you, if I go to one interrupt source, right? So even if there are another interrupts, they are not going to serve it until I finish this interrupt. That's why you should not write. That's what you should not write too much instructions here. Otherwise, this is going to delay executing other interrupts. Okay, is that clear, guys? Again, you don't need to do that. I'm just explaining. It's done automatically. Nested interrupts are not allowed, right? So after I finish executing one interrupt, now I'm going to look at other interrupts. Okay. Even if the other one, so if I'm executing one interrupt and another interrupt came, and this one, the new one has higher priority. It doesn't matter. It does not matter in this case. Okay. So because nested interrupts are not allowed. And then after that, after that, the CPU should resolve the interrupt vector, and from the this is the beginning address, so it has to get the beginning address from this location, as I explained, and it has to put this one in PC in order to branch to the interrupt subroutine. This is step number 6. Step number 7, here inside the interrupt subroutine, you have to cancel the interrupt request. As I told you, this is your responsibility. Okay, everything I explained before, it was not your responsibility. I'm just explaining how it works, but you don't need to do it. But this is what I explained. This is what you have to do, right? So you have to write an instruction in the interrupt subroutine in order to clear the interrupt. Okay. Next step here, we are going to execute the subroutine. And again, look what I wrote here, guys. You can use all the register. You don't need to push and pull. You can use all the register, and don't worry about interfering with the main program, because I told you this is done automatically. All the register are pushed and they are gonna return automatically. So you don't worry. You don't need to worry about that. So okay. So after you execute any interrupt subroutine, guys, all the register are gonna get their initial values back, right? The last step here, so here inside the interrupt subroutine, we're going to execute from the beginning address, we're going to execute an instruction until we find RTI. RTI, this is return interrupt subroutine, okay? So what this RTI is going to do, this RTI is going to take the return address similar to RTS. Look here, guys. Very important to understand. I told you how RTS works before. So what RTS is doing, RTS takes the return address from the stack and put it in PC to return it back, right? RTI is going to do this exactly same thing as well. So it's going to take the return address from stack, put it in PC in order to return it back, okay? So on top of that, it's going to do one more thing, okay? What it's going to do is going to pull all registers back, okay? So that means RTI is similar to RTS, but it has to do one thing more, okay? One thing more. It has to pull all the register from stack, okay, guys? So this is the whole story. So let me quickly go through it again, and then before I move forward. So quickly. So the beginning of any interrupt cycle should start, guys, when the device or the interrupt source set as the interrupt flag bit, right? This is the beginning, okay? Now, the CPU has to decide, should I serve this interrupt or not? To decide, number one, it has to see if it is enabled or not. So it has to it has to check I bit, also the local interrupt enable bit, okay? Number two, it also has to see if this is the only interrupt or this is there are multiple interrupts, but this one has the highest priority, okay? If this is the case, so now yes, I'm gonna serve it, okay? To serve it, automatically the CPU is gonna push all the registers to stack, right? This is number one. Number two, CPU is going to disable any further interrupt by setting I bit, because nested interrupts are not allowed. And now we're going to move from the main program to the beginning address. So we need to get the beginning address, okay, which is stored in the interrupt vector, as I said before, and then you can put it in PC to branch to the interrupt subroutine. After that, so steps from 7 to here, this should be inside the interrupt subroutine, right? So inside the interrupt subroutine, you should cancel the interrupt request by clearing the interrupt flag bit, right? This is what you have to do. Now we're going to execute the instruction you wrote in the interrupt subroutine. Finally, we're going to write RTI at the end in the subroutine. I already explained how RTI works, guys. So RTI, it is similar to RTS. It has to get from the stack the return address and has to put it in PC in order to return back to the main program. That make sure. On top of that, it has to pull all the registers back. Okay, again, you don't need to do that. It's done automatically. Any question, guys, before I move forward? Okay. So here I in this slide, I just summarize what you have to do in programming, right? Based on what I did before. Number one, in the main program, you need to initialize the interrupt vector. This is what you have to do, right? So for example, if I go back here, this is the org, this one. You have to tell the CPU what is the beginning address of your subroutine, okay, interrupt subroutine. Number two, also in the main program, we are going to do some kind of configuration, but this configuration is different from one interrupt source to another, right? So as I'm going to explain later, for example, if you when you program RTI is a timer. When you program a timer, I have to do configuration about I have to set the time out. I have to tell the timer, please timer interrupt me every 1 millisecond, every 20 millisecond, or whatever. You got what I'm saying? That's what I mean by configuration. I didn't explain it before because this is not general. This is specific. It depends on it depends on the type of interrupt source. Okay. For IRQ, as I'm gonna explain right now, for IRQ is just one pin. Every time there is a falling edge, okay, you trigger interrupt. You can actually select it's so it's pin. Once every time there is a falling edge coming from a sensor, from a device, whatever, okay, you trigger interrupt. So actually here you can select, do you want to trigger interrupt when there is falling edge, or when there is low level, when it is 0 volt? So you have this, you can select. Again, I'm going to explain it right now, but that's what I mean by configuration. So you need to configure the interrupt. Okay, so I'm going to explain this one later. This also you have to do in the main program. Number three, for sure, you have to enable interrupt. And to enable interrupts, as I said, you have to do two things, as I said, the global and local. Okay, guys? This is what you have to do in the main program. Now, what should I do in the interrupt subroutine, inside the interrupt subroutine? Number one, it only two things. Number one, you have to clear the interrupt flag bit, right? As I said before, don't forget this one. Otherwise, you are gonna have continuous interrupts. Number two, you have to end the interrupt subroutine with RTI, right? Instructions. That's it. That's everything. Now, before I move now what I'm gonna do, guys, I'm gonna apply what I taught here in this slide for two. I'm gonna be more specific now. Everything I explained so far is general for any interrupt source. Now I'm gonna be more specific. I'm gonna explain IRQ and RTI. But before I do that, please, do you have any questions so far? Because this is the nature of this course. I'm gonna build on what I explained before. So if you didn't understand what I explained before, it may be difficult for you to follow up. That's why, if you have any question, just unmute to talk to me before I move to IRQ. Okay, guys? Okay. So in this chapter, guys, I'm gonna explain two interrupt sources. One is called IRQ and the other one is called RTI. So first of all, before I go to the details, tell us what is the difference. What is the difference between them? I'm gonna tell you quickly what is the difference. Real-time interrupts or RTI. This is easy. This is just a timer. This is a timer. So once you set the timer, you can tell the timer. So this is a microprocessor, right? And this is here. Microprocessor can tell the timer, I need interrupts every, for example, 10 milliseconds. Is that okay? So once a microprocessor do that, so what's going to happen? You are going to have microprocessor is going to be interrupted every 10 milliseconds. So there is interrupt every 10 milliseconds automatically coming from the timer, right? So this one is used in the application. If you want to do something, related to time, like if you want to create a delay, if you want to wait for some time, or in case if you want to do something periodic, like in flashing, you need to turn on off. So one interrupt on. That means, here, very simple. When you configure the timer to 10 milliseconds, that means you are going to have interrupt every 10 milliseconds. That means the interrupt subroutine is going to be executed every 10 milliseconds. So this is used if you want to have like a frequent, you want to do frequent action or frequent event, right? So frequent. Anyway, I'm gonna explain later in detail. So this is for RGI. What about IRQ? Okay, I'm gonna tell you. IRQ, if this is the microprocessor, right? Microprocessor, you have pin, external pin. Okay. So as I told you, every time there is a falling edge here or low level, this is something you can select, right? So this is what I said, configuration. You can select. Do you want to trigger interrupts when there is a falling edge or when there is a low level, right? So every time there is a falling edge, you trigger interrupt, you execute a subroutine. That's it. So this is IRQ, interrupt subroutine, right? So every time there is a falling edge, you execute a subroutine. Every time there is a falling edge, you execute a subroutine, and so on. Someone can ask me where this falling edge is coming from. It depends on your application for sure. It may be, maybe this falling edge is coming from a sensor. Like for example, there is, as I explained before, sensor to sense a train is coming, so you can give this signal, okay? Or it can come from fire alarm, from wherever. It's up to you, right? Just the way it works, every time there is a falling edge, you trigger interrupt. This falling edge can come from a device, from a sensor, can come from a switch, wherever it comes from, okay? So I think now the difference is clear. Okay, so one of them, RTI is a timer, right? IRK, it has external pin, right? And every time there is a falling edge on this pin, you trigger interrupt. So now I'm gonna start with IRQ first. Okay, so number one, first you told us IRQ, it has external pin. Yes, that's true. So tell us, where is the pin? Okay, the pin is here, guys. PE1, the second pin here, second one. It's called PE1. This is the interrupt subroutine. IRQ, sorry, this is IRQ. This is the pin for IRQ. That means every time there is a falling edge here on this pin, right? So if you have a sensor, you can connect the sensor to this pin. Every time there is a falling edge on this pin, you trigger interrupt. Is that okay, guys? Any questions? Okay. Remember, RTI, it does not have external pin. This is a timer. This timer is inside the microcontroller. So inside the microcontroller, there is a timer. This timer is connected to microprocessor to trigger interrupts. So there is no external pin here. This one, it has external pin. Okay. Now, look, I'm going to go back now. As I told you, I'm going to always come to this slide here to explain. This is, again, as I told you, this is in general, okay? So I'm going to explain in details how can we do everything here for IRQ. So let's start with here. Number one, you have to initialize the interrupt vector. Is that okay? That's what I told you. How can you use that, guys? Org FF2. You have to use FF2, right? Why? Because this is for IRQ. If you go to the table here, IRQ, it has to be FF2, right? So you have to use this number, right? When I explain RTI, I'm going to use this number. When I explain any timer channel, I'm going to use this number. Very easy, right? So once you learn how to do one, how can you program one interrupt source? All of them is the same. So here, so you have to write this one as I told you in your program, guys. And IRQ, ISR, this part, this is the name of the subroutine, right? You can put any name, right? But you have to put the name here. Whatever name you put, just you have to put the same name here. Because as I said before, if you have a name like IRQ, ISR, you have a name this way, I tell you this name is going to be replaced by the address. So this actually is going to be like address, replaced by address. Okay. So now you have to use this instruction, guys. This number one. Also, your subroutine, this should be the name of your subroutine. Okay. Now let's move to the next point. Next point is configuration. Do I need to do configuration here for IRQ? The answer is yes. Okay. What do you need? Why do you need configuration? Because they give me the choice. Okay. The choice is, we have a pin here, guys. Do you want to trigger interrupt when there is a falling edge or when it is 0 volt? When it is 0 volt. Okay. So it's up to you. You can select, right? So this is the configuration we have for IRQ, right? So how can we do that? I'm going to explain now how can you do. It's just one bit. If this bit, if you put 0 or 1, you can select this one or this one. That's it, right? Um, the other thing also I need to explain, as I told you before, enable bit, right? I told you every interrupt source should have one bit for enable or disable, right? That's what I said, right? So now I'm gonna tell you where are these two bits. These two bits, guys, are in one in register. This register is called INTCR, interrupt control register. You can just use this English name, right? You just use this English name. You don't need, it should have this address actually, but you don't need to use the address. Just use the English name, because this one is already defined in the file we include, right? So this one is similar to DGRA, something like that, right? So here, actually here we should use the address, but we don't use the address because it's easier to use English names. Okay, so same thing here, interrupt control register. This is the name of the register we can use. This register, as you see here, guys, this is the interrupt control register. This register has two bits, bit number 7 and bit number 6. That's what we care about. In bit number 6, this is the enable bit. Okay, guys. So if you put one here, you actually you enable IRQ interrupt. If you put 0, you actually disable IRQ interrupt. Is that okay? So this bit here, so this, as I told you, just one bit for enable or disable IRQ interrupts. Okay. Again, I said it before. I'm gonna say it again. What I mean by enable or disable interrupts, guys, very simple. What I'm saying, every time there is a falling edge, for example, interrupt subroutine is executed. So every time there is a falling edge, interrupt subroutine is executed, right? This is if the interrupt is enabled. If the interrupt is disabled, okay, if there is a falling edge, nothing is going to happen. So we're not going to execute the interrupt subroutine. Nothing is going to happen because it's disabled. Anyway, so what I'm saying, we have one bit here, guys, for enable and disable. Also, we have one bit here for configuration. Do you want to trigger interrupt when it is falling edge or when it is low level, right? How can you do that? Yeah, if you put here 1, as you see here 1, that means it's falling edge. If you want to put here 0, that means it is low level. Is that okay, guys? So now let's see what numbers we are going to use right now. Look here, guys. I want to enable interrupt, so I have to put 1 here. Okay. So now if I wanna trigger interrupts at falling edges, so I have to put 1 here, right? So it has to be 1100, which is C0. So this is one number we can use, C0, right? There is another number we can use, 40. This is when you put 0 here. This is in case of low level, right? So usually we're going to use two numbers, either C0 or 40, right? 40 in case you put 0, 1, right? This is if you want to for low level. If you put here 1 in case of falling edge, very easy, right? So this is also something you have to put in the main program to do to enable interrupts and to configurations. So you have to write this instruction as well. Any question, guys? And at any time you can enable or disable interrupts at any time. So maybe during the program you decide, and that's what you're going to see later as well. We're going to have example on that. So you at any time in your program you may decide to disable interrupts, right? So so that's all what you have to do. Just write this number, this value to this register. That's it. Any question, guys? Great. So now also you have, don't forget CLI as well. You have to do CLI as well, right? So now, as I said before, inside the interrupt subroutine, you have to do two things inside the interrupt subroutine. Number one, you have to clear the interrupt flag bit. Also, you have to end it with RTI. Okay, that's okay. The only case that the interrupt flag bit is automatically cleared, right, is only IRQ. This is the only case. Is that clear, guys? So that means you don't need to write this instruction in IRQ. But again, this is just exception. This is the only case. But all the interrupt sources, you have to write a command to clear the interrupt flag bit. In IRQ, you don't need. It is done automatically. Okay, guys? Any question before I give you example? So that's it. This is how can you program interrupt, IRQ interrupt. Number one, you have to put this one, right? Number two, you have to write this instruction. This instruction has to do two things. It has to enable interrupts. Also, it has to configure interrupts to for falling edges or low level. Here in the interrupt subroutine, you don't need to write an instruction to the interrupt flag bit, you have to write RTI at the end, and that's it. And also you have CLI here. Any question, guys? That's it. Very easy. Very easy. And even any other interrupts, I'm gonna follow the same structure here, right? So I'm gonna talk about this one. I'm gonna talk about this one. That's why I'm telling you all of them almost the same. If you know one, all of them almost the same. Okay. Any question, guys? Before I show you example. Great. So here in this example, what we want to do here is last time I explained, you remember when I press a button, okay? I want to shift the LED. When I press a button, I want to shift the LED. That's explained last time, okay? I want to do the same thing, but last time we did it in the main program. When I explained it last time, or in chapter 3, I explained every time you press a push button, you shift LED. You press push button, you shift LED, right? You shift the LED. I explained this program in chapter 3, but I wrote the code in the main program. So again, as I told you, the good thing about interrupts, you can do the same thing in different ways, right? So now how I can do the same thing, but I want to do it using IRQ, so that I'm gonna leave the main program free to use it for something else. So every time I press a push button, right? So I wanna shift LED. So I wanna write this one in I want to do it using IRQ, so that the main program is free. Is that okay? So how can you do that? I'm gonna okay. So the way you are gonna do it, number one, you have to configure the IRQ interrupt as I explained here, right? Number two, once you do that, guys, what's gonna happen every time? This is we have a pin here, as I told you, PE2, right? So this pin, every time there is a falling edge here, right? This falling edge, this one should trigger interrupt and execute the interrupt subroutine. So here in the interrupt so every time you press, you are going to execute the interrupt subroutine. And in the interrupt subroutine, in the interrupt subroutine, we're gonna shift the LED in the interrupt subroutine, right? So as you will see right now. So let me choose the program. So number one here, guys, as you see, I have to write this instruction. So I have to write this one to configure the interrupt subroutine, right? So I have to write this one. FF2, and this is the name of the subroutine, guys, and this is the main program. Please, now as I told you, your program is not going to be in one place anymore. So this part is the main program. This is the main, right? And including subroutines. So even if you have subroutines here, you can put it here. Not interrupt subroutines. I'm talking about the subroutines we had before. And now we have a number of interrupt subroutines. Here in this program, we use only one, but in other program, we use more. That's why I'm telling you, we have main program, guys, and then we have interrupt subroutines, a number of interrupt subroutines, right? So now your program is not going to be written in one place anymore. Let me say it again, because this is important. What I'm saying, your program is not going to be written in one place anymore. You are going to write one part here in the main, one task here in the main program, one task in one interrupt subroutine, one task in interrupt subroutine, and so on. Okay. So let me see what we have to write in the main program. So in the main program, I have to do the configuration, as you see here, guys. So here I configure port B, because I'm using an LED. Also, what happens here, I'm going to tell you what I did something here very interesting. You know, as I explained last time, when you press a push button, you are going to generate something like that, as I explained last time, right? But you are going to generate something like that on port H, PH0 to PH4, right? So here, this is a microcontroller, right? We have here port H, PH0 and to PH4. Any pin of this, you are gonna get a signal like this one, right? But IRQ is PE2. This is IRQ, right? So if you want to use this, so what I did, I connected external wire. For example, if I use PH0, for example, if I use the push button of PH0, okay, so I connected external wire between PH0 and IRQ. Why? So that when I press a button, I'm gonna generate a signal here this way. This signal is gonna come here to trigger interrupt. So when there is a falling edge, you are gonna trigger interrupt. Is that clear, guys? Let me show you. Let me just elaborate, or let me go. I just want to go to chapter 3 again to show something. Okay, look here. Just I want to make it clear what I mean. Look here, guys. Okay, let me remove this one. Maximize it. Okay, let me. Okay, look here, guys. This is PE. I think BE1 or BE2. I don't remember. BE1, right? It BE1. We have BE1, BE2 here anyway. I think IRQ is BE1. I will check right now and tell you, right? So what you have to do, you have to connect external wire from here, from BE1 or BE2, whatever IRQ, and then I can connect to, for example, BH0. I can connect wire to BH0, and then after that, I can use this. I can use this push button here, guys. Right? So every time I press, I press this push button, BH0, so there is a signal like this. This signal is going to be generated in port H, and this wire is going to connect it to IRQ to trigger interrupts. Okay, that's what I meant. Okay, so let me. I told you it is. I think the second one, BE1. I'm sorry. So IRQ. Look here, guys. IRQ is BE1. The second bin. Second bin is BE1. Okay, just give me 1 second. Okay, guys. So is that okay? So what I did, I connected a wire from BE1 to BH0 so that every time I press a button, I trigger interrupt. Okay, guys. So now let's come to the program here. This is the program here. So let's see the configuration. This is similar to the program I taught last time when I explained to push buttons. Is that last time or anyway before in chapter 3 anyway? So here what I'm saying, guys, here number one, you have to write, for sure I explained, you have to write this one in order to tell the microprocessor where is your program. So I have to write this part, this one here. Also I have to configure port B, port H, right, as output. This we always do that. I have to enable. So all of this, just these are the configuration we always do. We also you need to disable. Make sure you disable the 7 segment. You enable the LEDs. Okay, and now I put here one for port B in order to I turn on the first LED. Also, you have to write these 2 instruction, guys, right? In order to enable IRQ interrupts, and also I'm asking to respond to falling edge. Is that okay? And then you have to enable all interrupt CLI this way, okay? And now, because this is a very simple program, I don't have anything to write in the main program. I put something like that. But usually you are not gonna do that. You understand what I'm saying, guys? So what I did here, I'm branching here all the time. So this is the main program, right? So all the time it's gonna be branch here, branch this way. Every time there is interrupt, it's gonna go execute the interrupt subroutine and come back. If there is interrupt, to go execute interrupt subroutine and come back, right? I did that because again, this is just a simple program. I don't have task in main program. But actually, if we have a task, I have to write the task here, right? So I have to write the task here and have to loop back. Okay. Okay, guys. So after, based on what I did right now, you know what? Based on what I did right now, every time you press a button, you actually execute a subroutine. That's it. Every time you press the push button, you trigger interrupt and then you execute the subroutine. Now, what do you want to do? You have to write it here in the interrupt subroutine. So this is the interrupt subroutine here. Okay. So every time you press a button, you are going to execute this part. So just put it here, just write here what you want to do. Okay. The good thing, again, guys, listen to me, because what I'm going to say right now very important, right? The good thing about programming interrupts is the same programming, the same configuration or the same programming I did right now. You can use it for any any program that is using IRQ. You got what I'm saying? All what you have to change, just what you are gonna write here, right? So if you want to IRQ to do something, you can different, just put it here. You will see right now what I mean. Okay. So now all what we have, guys, we have a subroutine. This one IRQ interrupt subroutine, and at the end I have to put RTI as you see here. And every time you press a button, you trigger interrupt and you call this subroutine, right? So number one, what do you want to do? What you want to do here? As you see here, I'm gonna write here the debouncing code, right? Because if you don't write the debouncing code, what's gonna happen is, look, guys, you may trigger interrupt here, and then you trigger another interrupt here, and trigger interrupt here. You press one time, you're gonna trigger interrupt multiple times. So here I put this code for debouncing so that I can make sure every time I press a button, you trigger interrupt only one time. Is that okay? And then after that, as you see here, I'm gonna shift port B, right? This is exactly similar to the program I explained in chapter 3. But the only difference, again, I moved to this task from the main program. I put it in IRQ interrupt subroutine. Is that okay? So here I shift port B, and if it is not 0, so I'm gonna come here to return. If it is 0, so I have to return. When you shift all the way to the end, right? So you have to return the one back to the beginning again, as I did here. Okay, guys, any question? Is that clear? I'm gonna show a video now, but before I show the video, guys, I want to tell you, look what I did here. Something very interesting. Look here. If I remove this 3 instruction, I put different instruction. Now this program can do something different. That's it. I don't need to change everything, just this part, right? For example, if I put something like load accumulator A port B XOR with 1, right? And then store back to B. You know what I did here? I toggle the LED, right? I toggle LED 0 when you press the button. So every time, so now the program is doing something completely different. And instead of shifting port B, no, what I'm doing right now, every time you press the push button, you toggle the LED. So that's what I want to say. The same program, if you just change this part, your program can do something completely different. See also what I did here, guys. Sometimes this is also something very important you should understand. Look here, guys. Sometimes you want to count number of events. For example, you have sensor this way. This sensor transmits infrared light, so you cannot see this light, right? And then there are some cars or some people are crossing the gate, and I want to know how many people entered. The store or whatever. So I can have this setting. So every time, for example, assuming, and this one here, every time you cut this line, you actually are gonna making falling edge. And this one, I'm gonna connect it to the microcontroller. Is that okay? You understand what I did? So what I did here, guys, is I want to count how many people enter. So every time one person enter a store, for example, this person cuts this line infrared light, and then this trigger interrupt here. In other words, every time one person enters the store, you execute a subroutine. That's it. Okay. So now I want to count. So what should I do? Look here what I did. I can just say increment count. So I have a memory location. This memory location is called count. I increment count because I want to increment how many people enter the store. And then you can take this count, you can display it on the LCD, on the 7 segment or anything, right? Uh, uh, or you here what I did, I want to display this count on port B, as you see here. Okay. Is that clear, guys? So this is you can count. So this events can coming from different sources, right? Like can be cars. You want to count how many cars. As I'm gonna explain later, it can come from a motor. Okay, as I'm gonna explain later, you have like a motor. Every time you put here like a disc. This disc has 2 holes. Every time the motor make one full rotation, you are gonna make 2 pulses here. So now I want to count how many events we have, how many events we made. So you can use IRQ for something like that. Any question, guys? Okay, just 1 second. Any question, guys? Okay. Now I want to show you before I tell you, or let me first explain. I'm sorry. How can you do the same thing using C language? And then I'm going to choose a video. Again, the good thing is configuration is easy. Once you know how to configure, how you configure it, you can almost use the same configuration in different programs. You got what I'm saying? To do different things. So let's see here. Now in C language, how can you do what I explained in C language? Look here, number 1. This is the main program, right? So you have a main program here. Also, this is the interrupt subroutine program. This is the interrupt subroutine program, right? Uh, in the interrupt subroutine program, guys, you should put here void. You should put here the word interrupt. So the word interrupt here is a keyword. So this is in instructions, the word interrupt, right? And then you put here a name. Here it can be any name. So you can put any name. But usually we write a name that can tell what this instruction is, what this subroutine is doing, like IRQ underscore ISR, right? So usually you have to select a good name, but you can put in any name. But for interrupt, you have to use the word interrupt. Now, this number, this number can tell the microcontroller what this interrupt is for, this number, right? So for IRQ, we always use number 6. Okay. For any interrupt source, we use a different number. Is that okay, guys? So how can you come up with this number? How can you get this number? Very easy. I think I put it. Let me come here. So it's just the order here, but to start counting from 0. So here, this is 0, 1, 2, 3, 4, 5, 6. That's why I told you we are going to use number 6 for IRQ. In case of RTI, we're going to use number 7. Okay, 8, 9, 10, and so on. Is that okay, guys? So this number is very important. This number can tell what this interrupt subroutine is for, right? So here, I think that's easy now. Look here, guys. So now, similar to what I did in assembly, we have two parts. The main program is here, and also the interrupt, the IRQ interrupt subroutine is here, right? And you have to use this number, as I told you, number 6. Don't forget it, okay? In case when I come to RTI, I'm gonna tell you this number should be number 7, right? So, but it can be any name, right? As I said. So here is the interrupt subroutine. So what I'm gonna do here is similar to what I did here, exactly same thing, and that's what I did. So that means every time there is interrupt, guys, so this subroutine is going to be executed. this subroutine is executed. Every time there is a falling edge on IRQ, this subroutine is executed. So now I'm going to do the same thing as I did before. Number one, this is the debouncing code. Number two, I'm going to shift to port B. As you see here, I'm going to shift to port B. And then if port B is equal to 0, it's, as you know, port B is going to be 0 once we shift all the way. So this one is 1, shift all the way. Now all of them are 0, 0. So I have to return it back to here, right? This is a program I taught in chapter 3. Okay. So here, as you see here, number one, you are going to shift port B, and then if port B is equal to 0, you put 1 here. So again, every time there is a falling edge, this subroutine is executed, right? Some students are confused here, guys, because I don't write instruction to to call or execute this subroutine. Yes, because this is the basic definition of interrupts, right? Interrupts, you call it's similar. You are calling a subroutine, but you don't need to write instruction to call the subroutine, right? Because the subroutine is called automatically by when there is an event, as I said before. Anyway, so again, very easy. So in C language, guys, you have to write here just number 6 here, and then write whatever you want to write here. Okay. And now, okay, now how can I configure the IRQ interrupt? So I'm going to show you now. Here we are using 7 segment, right? So also we are using here LED enable. So all of this is similar to what we did before. So here for IRQ, all what you can do, you can say IRQ underscore enable. So this instruction actually, or you can write actually INTCR interrupt control register C0. So you can write this one this way, or you can say IRQ underscore enable, whatever. Both are okay. Because actually, if you go look inside this function, you will find this function is actually you will find this instruction, this one here, move C0 INTCR is written inside this function, right? So it's already written here. So if you want to say IRQ underscore enable, that's totally fine. If you want to use INTCR equal 06 C0 should be okay. I want to tell you here, this one is used if you wanna configure the IRQ to respond to falling edges. This one, right? So now, if you wanna, for some reason, if you wanna respond to low level 0 or low level, in this case, you can change this one here. You should not use this one, right? Because this one is only for falling edge, right? So you can say INTCR equal 40. You can put here 40, or you can go to the assembly inside this one and change the assembly. So let me summarize what I said before I choose a video, guys. Conclusion. Number one, now in C, I have 2 parts. This is the main program, and this is the interrupt subroutine. Okay. In interrupt subroutine, you have to write void, you have to write interrupt all the time. Here, because this is IRQ, you have to write number 6, and then you can put any name. Okay. And this is the interrupt subroutine here for IRQ. In order to configure the IRQ interrupt subroutine, just use this one. Very easy, right? Very, very easy. Okay. Any question, guys? Okay. I'm going to show now the video. It will be similar to what I did in chapter 3. By the way, I want to tell you something important. In this chapter, I'm going to repeat several programs I explained in chapter 3. But in chapter 3, I put all these programs or I put them in the main program, right? In the main program. Here, I'm gonna put them in interrupts. So I just want to tell you a tasks. Any task that can be done, you can put it in the main program, or you can put it in interrupt subroutine. You can do the same thing. Okay. So now let me show you the video for this one. Come in. Okay, thanks. Okay, guys. So I'm going to choose a video now. Chapter 4 videos. Okay. which one? Yeah, shift LED IRQ. Okay, let me do this one. But let me share. Okay, we don't need the voice. Look here, guys. So every time I press a button, I trigger interrupt. Right? Again, don't be confused. This is the same program I taught in chapter 3. Okay, same program, but here I'm doing it using interrupts. So every time I press a button, I trigger interrupt, and the interrupt subroutine shifts the LED, as you see here. Can you see? Yeah. Okay, guys. Uh, but again, don't forget, if you want to do this, guys, you have to connect a jumper. Okay. If you forget the jumper, it's not going to work, because when I press a button, I'm going to generate a pulse on port H, but IRQ has to be on PE1, right? So you have to connect external wire. I don't think it's shown. It's shown here it's not shown in the video. Let me see. The wire is not shown. I think it was shown in another video. It's not shown here. Okay. I think it's shown in another one. Let me see here. I think this is a different one, but I want to just show you the wire. Yeah. So here I was at home, so I didn't find when I recorded this video. I was at home, so I didn't have like a nice jumper. So I just put this wire, but that's what I want to say. You have to put. Hopefully you can see it. You can see here. So I just put this. That's what I found in my home. But you should use a nice jumper. Okay, guys. Anyway, any questions? I think that's easy, right? So any questions? Okay. Now let's move to the next one, RTI. Okay, guys. So let's now move to the second one, RTI. I told you guys RTI is different from what I explained right now. RTI is a timer, so it does not have an external pin. It is a timer, right? So this timer, all what you have to do, just you can set the time out. If you set the time out, for example, 1 millisecond or so you are gonna trigger as long as the RTI interrupt is enabled, you are gonna trigger interrupts every 10 milliseconds or whatever the time out is. Okay, that means you are gonna run the subroutine every certain time, periodic, right? This is RTI. So let me explain RTI now. Let me see what is the time. So I'm going to explain how to program it. You will see it is just similar to what I did before. There are just very small differences. Here, I told you RTI can be used if you want to generate periodic interrupts at a fixed rate, for example, certain time, and you can configure this time. So you can select this time. I'm going to tell you how can you do that. Here, number one, in the main program, you have to write this one as I told you guys. But again, this is different from what I did before. Here I used a different number. What I did in IRQ, it was FF2, I guess. This time it has to be FF0. And I already explained how can you come up with this number, right? And this is the name of the subroutine. So you have to do that, is this part, in order to tell the microprocessor where is the beginning address of your subroutine. This is number one, right? Number two, you have to do configuration. So what kind of configuration here? Remember, it's a configuration in IRQ was about do you want to trigger interrupt when it is a falling edge or zero level, right? Here it is different. Here is the configuration is the timeout, right? So the configuration here, you need periodic interrupts after how much time, right? This is the timeout. So timeout here, as you see here, guys. So the way you have to do it, to do the configuration, is we have a register. This register is called RTI CTL. RTI CTL. This register should have this address, right? So all what you have to do, you in order to set the time out, you have to write a certain number in RTI CTL. You have to write a certain number here to to set the time out. Okay, so I'm gonna tell you. So and that's very easy. All look here, guys. That's very easy. You have to come up with a number. That's what I'm gonna explain right now. How can you come up with this number? So you have to come up with with a number, and just you have to write it in this register. That's it. Once you did this one, you asked the timer, please timer interrupt me after a certain time periodically. Is that okay? So now the question, how can you come up with this number? That's what I'm gonna explain right now. So this is the register RTI CTL. As you see here, this register is just give me 1 second. Okay. Yeah. So this is the register, guys. The first 4 bit of this register, I'm gonna call it N. So 1, 2, 3, 4. So these 4 bits they should have a number. I'm gonna call it N. And these 3 bits, they should have a number. I'm gonna call it M. Right. So M can take a number from 0 to 7, right? Because it's 3 bits. N should take a number from 0 to 16. I'm sorry, to 15, because it is 4 bits. Is that okay? So based on the number you select for N or M, you can select different time. Okay, that's good. But how can I come with this? With how I can come with the relation between this number and the time out? The relation is here, guys. Time out should equal N plus 1. Again, N is the value put here, and 2 to the power M plus 9 divided by 8. This is the relation, right? So you have to select N and M in such a way that you get a certain time out, right? So, but this is too complicated. Can you make it easier? Yes. So if you come here to this table, guys, I put here all possible cases. So this is for N. As you see here, this is all possible cases for N, starting from 4 zeros to 4 ones, right? And this is for M, starting from 4 zeros to 3 zeros to 3 ones, right? For M, as you see, right? And then the number I give here, you have to, this table actually doesn't give you the time, but it gives you the numerator, right? So this is the number given in the table. So you have to divide this number by 8 in order to get the time out in microsecond, right? So for example, if you select this one here, guys, this one, if you divide this one by 8 microsecond, right? So you are gonna make a delay every 10.24 millisecond, right? So let me say it simply. If you look here, guys, you can see the minimum time out you can get is 0.128 millisecond, as you see here. This is if you put 000 in N, and if you put 001, as you see here, in M. So if you do that, if you put this value, right, in this register, if you put this value in this register, you actually are gonna have delay. This is the smallest delay we can have, or time out we can have, 0.128 millisecond, right? So where is the maximum delay I can have? This is the maximum delay I can have is here. This is when you put 1 here and 4 ones here. So all of them are ones, right? So this actually is going to be corresponding to, so if you put here 1, right? And you put here actually 1, and this one has to be 0 anyway. So this one is corresponding to the number 7F, right? So 7F, if you write 7F in this register, you can have this delay, right? Okay. So now, what if I need this one? If you need this one, guys, so it has to be this one here, 1001. So let me see it here, 1001, and right, this is in for M, it is 001, right? This number is right 1, 2, 4, right? So this one has to be 4, and this one is um, 9, 49. Yes, it's 49. Okay, so and so on. So for any value here, guys, you have to see what is the value of m, what is the value of n, and you have to write this value to this register in order to make this time out. Is that okay? I want to tell you something important. Look here, setting the time out here is not flexible, because first of all you don't have all the numbers. You just have to select. You have to, for the time out, you don't have to all the numbers. You have to just select numbers from, you have to select from this table, right? So yes, RTI does not give too much flexibility to set the time. However, the good thing in chapter 5, we have a timer system. In the timer system, we have much flexibility. It's going to be much easier. We're going to set the time out in a different way. It's going to be much easier way. Okay, guys? So this is the first thing you have to do. Any question, guys? Is that okay? So you have to see you have to decide what is the time out, and then you have to come up with the value of m and n, and then you have to write this instruction this way. Okay. Okay. So 7f. By the way, I don't think we are going to use all these numbers. Usually I use this number, usually, or this number. Okay. Or maybe these three numbers should be enough. If you know the three numbers, should be enough. This one here, right? And this one here, and this one here. This should be more than enough, right? So if you want to make a delay every 131 millisecond, just write this instruction. Is that okay, guys? This is number one. Number two, similar to any interrupt source, I have to tell you where is the enable local bit, right? Also, I have to tell you where is the clear interrupt bit. You remember the clear interrupt bit? This is the bit you have to clear in the interrupt subroutine, right? So let's start with the enable local bit. So where is the enable local bit? This is the enable bit. This one is in this register, CRGINT here, right? So in this bit, as you see here, guys, if you write one here, you enable. If you write one, you enable interrupts. If you write zero, you disable interrupts. That's it. Very easy. Very easy. So you write here one to enable interrupts, zero to disable interrupts, right? So, for example, look here, guys, bit set, CRGINT, and then 80. 80, as you know, 80 is 10000000, because you wanna set this bit. So if you wanna enable RTI interrupts, you can just use this instruction. Very easy. You can just set this bit. If you wanna disable RTI interrupts, you can just say bit clear. It's the same instruction, but just to put bit clear in order to put zero. Very easy, very trivial, right? So it's just one bit in a register. All what you have to do, just if you want to enable interrupts, you just put one. If you want to disable interrupts from RTI sources, here this is local enable bit. This is not the global, right? So this is local. So this bit can enable or disable the interrupts of only this source, RTI source. Is that okay? This is one thing. The other thing now is the interrupt flag bit. I told you for the interrupt flag bit, the bit here, okay? It's your responsibility to clear this bit, right? So, but there is something little bit weird here. The way you have to clear this bit, guys, is by writing one. So in other words, you can move 80. You can write one to this bit. Once you write one, so this one is going to clear the interrupt flag bit. This is the way it works. So let me tell you what I said in in very simple way. Okay, look here, guys. So if you want to program RTI, number one, you have to do this part here all the time. Yes, that's easy. Number two, you have to do this instruction. Yes, but you have to select what number here for the timeout. This number two. Number three, you have to do this one, right, in order to enable interrupts. Number four, in the interrupt subroutine, you have to put this one. Very easy. All the time we will do that. The only change that may happen is here I put 7f if I want at the time out every 131, right? If a different number, you have to put different number here. Other than that, everything is the same, right? You got what I'm saying? Let's see what is the time now. Yeah, still we have 2 minutes. Okay, guys. So now I wanna show you. I wanna make a program. I wanna give you an example right now, guys. Okay. Um, here in this example, I finished programming RTI. I just want to give you an example. In this example, I want to make in this example, uh, I want to make flashing LED. So LED is going to be flashing on for 1 second, off for 1 second. Remember, this is what we did in chapter 3, and this is what I told you in chapter 3. Is it's not a good idea to do the way we did in chapter 3 because CPU was busy all the time, right? So now I'm gonna do the same thing but using RTI. So the flashing itself will be done by RTI, right? How I can do that? That's very easy. If I can ask the RTI to make frequent interrupts every 1 second, and in the interrupt subroutine, I'm gonna say flip the LED. That's it, right? So the microprocessor is gonna be free also, is gonna be free all the time, right? So, but there is a small problem here, guys. What is the small problem? Okay. If you look here, I want to make a flashing every 1 second as we did before in chapter 3, guys. Okay. So, but there is a small problem. The small problem here, the maximum delay I have here is 130 millisecond, right? So I cannot, 1 second is a very long time. 1 second is a very long time. So what can I do? Okay. I cannot change this one, right? The maximum delay is 130. Okay, I'm gonna tell you what can we do quickly. So I can have the maximum I can make, guys. I can have interrupt every 130, 131 millisecond, right? But actually, I need interrupt every 1 second because I'm gonna change the status of the LED every 1 second, right? I cannot do that. So what I can do, I'm gonna have interrupts every 131 millisecond, right? Periodic interrupts. And then every 8 interrupts, I'm going to flip LED. So at interrupt number 8, so number 1, number 2, number 3, interrupt number 4, interrupt number 5, all the way until interrupt number 8. At interrupt number 8, I'm going to flip LED. Okay, what you are going to do at interrupt 1 and 2 and 3, I'm not going to do anything. Just what's going to happen, interrupt 1, I'm going to go, are you interrupt 1? Leave. Interrupt 2, are you interrupt 2? Leave. 3, leave. 4, leave. Do nothing. At interrupt number 8, right? I'm going to say flip LED. Why? Because every 8 interrupts is going to be 8 times 131 millisecond is going to be around 1 second. You got the idea, guys? The idea is because I cannot trigger interrupts every 1 second. I cannot. The maximum is 131. So is what I'm going to do, I'm going to have periodic interrupts every 131 millisecond. And by this way, I'm going to count the interrupts at interrupt number every 8 interrupts. So this is interrupt 8, okay? And then interrupt 16 and so on. So every 8 interrupts, right? Every 8 interrupts, I'm going to flip the LED to make flashing every 1 second. Using the same idea, If I want to make flashing every half a second, so that means it has to be every 4 interrupts, right? Because 8 interrupts are going to make 1 second. So 4 interrupts are going to make half a second. So I'm going to continue explaining this last time, guys. Okay. Sorry, I spent 2 more minutes. Okay. Anyway, so see you. Bye.